Hello student, how are you? I hope everyone is fine. I am Gautam sir. Today I lecture surface area and volume class 10. Initially, you know the identities of surface area and volume. It is very important. And surface area and volume identities is very important. If you know the surface area volume identities, then you to able to solve the problem. And I explain one by one by quick method, quick revision for your exam purpose. Okay. Now, surface area volume from your NCERT textbook. Okay, from your NCERT textbook, exercise 13.1. Okay, but initially I explained the identities of all surface area volume and start from cube. Cube, what is the TSA, mean total surface area, 6 into a square, LSA, otherwise CSA, curved surface area, lateral surface area, 4 square, that is mean area of 4 wall when ceiling and floor are not including, only for 4 wall including, and volume is equal to a cube, that is mean side cube, cuboid TSA, total surface area 2 into LB, BH, LH, and CSA is area of 4 wall, 2H into L plus B without ceiling and floor, that is volume is equal to L into B into H. And next, cylinder is height and this is radius, curved surface area, CSA 2 pi RH, only for curve, not including base. So TSA including base. If you forget the identities, you write that way, 2 pi RH plus area of two bases, each base area pi r square, that is 2 pi r square. If you take common 2 pi r, so H plus R. This is the total surface area. Volume is equal to pi r square H. Now cone. This is the cone. And this is lateral edge, slant height. Slant height. And this is height. And this is radius. Slant height L, height H, radius R. So CSA mean only for outer surface area, not including base, pi RL. TSA including base, CSA plus area of base, pi r square. That is pi r common, L plus R, right? And volume is equal to 1 by 3 pi r square H. When, what is the relation between L, R and H? This is the 90 degree, the opposite of 90 degree hypotenuse. Apply the Pythagoras theorem. L square is equal to height square plus base square, R square plus H square. Okay, now sphere. What is the sphere? Spherical shape. And if you radius R, surface area is equal to 4 pi r square, total surface, normal surface area, that is sphere, mean total surface area. Volume 4 by 3 pi r cube. And if you take hemisphere, CSA, half of the sphere area, 2 pi r square. CSA means non including this base, and TSA means including this base. CSA plus area of base, that is 3 pi r square, or volume half of the sphere volume 2 by 3 pi r cube. Okay, so this is the identities of spherical surface area and volume, and these identities use each and every questions. So you learn these identities at first. Okay, now I start from NCERT textbook 13.1. I do not write the each and every question, because if you open your textbook and then you solve this. Now exercise 13.1. Now question number 1 tells 2 cubes of each volume, 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. So I draw, this is the okay, two cuboid joined end to end, and volume is given. And volume of cube is side cube. 64, A is equal to cube root of 64. Cube root of 64 make a prime factor of 64. 4 multiply 4, that is 3 pair is 1, that is 4 centimeter. So if we join this wise 4, 4, and height remain 4 and breadth remain 4. So only height remain 4 and breadth remain 4, but length is 8. So depending on join, if you keep breadth wise, otherwise height wise, so depending on your joining, so you always take L is equal to, I take L is equal to 8 centimeter, and breadth is equal to 4 centimeter, height is equal to 4 centimeter. Otherwise, you can take length 4 and breadth 8 and height 4. Okay, according to your choice, so you can choose anyway, but it is from a cuboid. So total surface area of cuboid 2 into LB plus BH plus LH. Now after that, put the value 1 by 1, 8 into 4, 4 into 4 plus 4 into 8. Now this is surface area, that is centimeter square. Okay, after that you do calculate the result. Now I move to next question, because very short revision. Question 2. Vessel in the form of a hollow hemisphere mounted by a hollow cylinder. Hollow hemisphere mounted by a hollow cylinder. Okay, mounted by a hollow cylinder. Vessel in the form of a hollow hemisphere mounted by a hollow cylinder. And the diameter of the hemisphere is 14 centimeters. So that is radius is equal to 7 centimeters. And total height is 13 centimeter. Total height of the vessel is 13 centimeter. So now height of the cylinder is equal to total height minus 7, because in a hemisphere radius 7, this is also radius, so this also 7, so 7 minus, that is 6 centimeter. Now find the inner surface area of the vessels. Inner surface area of vessel is equal to CSA of hemisphere plus CSA of cylinder. Okay, inner means inner surface area, that is this is are not closed, this is open and this also open. So this it is curved surface area. Curved surface area hemisphere is 2 pi r square and cylinder is 2 pi RH. Now you take common 2 pi r, so r plus h. Now put the value 22 by 7 into 7, 7 plus 6. Now after that you calculate. Okay, understood? Now I move to next question. You note down this portion and after that you do solve this. Okay, if you, I think it is clear because it is a very easy way I explain, and you draw the figure in exam also because figure is necessary. Now question 3, a toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere. So again draw a hemisphere. Again draw a hemisphere mounted by a cone. Cone, this is the cone, and radius 3.5 centimeter, and total height of the toy is 15.5 centimeter. So what is the height of the cone? 15.5 minus 3.5, because same concept, this is also 3.5, that is 12 centimeter. Find the total surface area of the toy. So you need the surface area, curved surface area of the cone, pi RL. So you need R L. So radius 3.5, I remove the decimal. So 5752, right? So now after that, applying the Pythagoras theorem, L square is equal to R square plus H square. 7 by 2 whole square plus H mean 12 square, that is 49 by 4 plus 144. 49 plus 576 by 4, that is 625 by 4. L is equal to 25 by 2, that is 12.5 centimeter. Now, inner surface area of the vessels. So therefore, inner surface area of vessel is equal to CSA of hemisphere plus CSA of cone. CS of hemisphere 2 pi r square and pi rl. Pi r take common, that is 2r plus l. This is the after that put the value 1 by 1 and you calculate. Now you move to question number 4. You pause the video, then you note down. I move to next question 4 because very short time. I want to quick revision for you. Now, cubical block of size 7 centimeters surmounted by a hemisphere. Cubical block hemisphere surmounted by, okay, surmounted by hemisphere. What is the greatest diameter of the hemisphere? Greatest diameter, side of the cuboid. Greatest diameter is equal to side of cuboid. greater diameter is equal to side of cuboid. Wait 1 minute. Okay, now side of cuboid. Now, what is the area? Area means this portion is removed because this is open circular portion. Area is equal to TSA of cuboid cube minus area of base of hemisphere plus CSA of hemisphere. Okay, so TSA is 6 into a square. Area of base means circular portion. Radius take r pi r square. CS of 2 pi r square. Minus pi r square plus 2 pi r square. Simplify 2 minus 1, 1 to plus pi r square. Now, what is the value of A is 7. If side is 7, then radius is also 7 by 2 because side is diameter. So radius 7 by 2 whole square. Okay. Now, after to calculate. Now I move to next question. Same way I draw another figure because this question is same. Okay, this question is same, similar. But this is depression. So that means this. Same way you draw the figure, same way you calculate, but here radius is equal to L by 2, side L. Okay. Now in terms of pi, you do calculate the result. Now I move to question number next 6. Medicine capsule. You read the question properly. Okay. You read the question properly first. This is the medicine capsule. Okay, and hemispherical end and total length. This is thickness is 5 millimeter and total length is 14 millimeter. Okay, 14 millimeter. What is the radius? The radius is 2.5 millimeter. This is also 2.5 millimeter. What is the length of the cylinder? 14 minus. This is 2.5, 2.5. That is mean 5 minus. So 5 minus 14 minus 5. Okay. So that is 9 millimeter. Okay, 9 millimeter. This is the height of the cylinder. And radius of the cylinder also 2.5. Hemisphere radius is 2.5. Now find what is the find the surface area. Surface area of medicine. CSA of cylinder plus 2 times CSA of hemisphere. CS of cylinder 2 pi RH and 2 times of 2 pi r square. 2 pi r common, h plus 2r. Now after that, put the value. R is 2.5, h is 9, r 2 into 2.5. Okay. Now next question I move. And always write the unit. This is millimeter square. Okay. Now next question. A 10 is in the shape of a cylinder whose height is, no, question number 7. A 10 in the shape of a cylinder surmounted by a conical top. If the height and the diameter of the cylindrical part, okay. 10 in the shape of a cylinder surmounted by a conical top. Noted? You pause the videos, then after that you note down. Okay, I move to next question. Question number 7. A cylinder. Okay, and 10 in the shape of a cylinder surmounted by a conical top. This is conical top, and height and diameter of the cylindrical part. Height and diameter of the cylindrical part. Cylinder height, I take H1. This is equal to 2.1 meter, and diameter is given, so radius is equal to 2 meter, and slant height of the top, that is L is equal to 2.8 meter, and find the area used for making the tent. Area used for making the tent, radius dimension, and also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. 500 per meter square. Okay. Now, tent is always find the CSA because only for outside design made of tent, only for, but base is not including here. So only for find the area of the CSA of cylinder and CSA of cone. Okay. So area of cone and area of tent is equal to CSA of cylinder plus CSA of cone. Cylinder 2 pi RH and pi RL, pi R common, 2H plus L. This is the CSA. Okay. Now you put the value here. 22 by 7 R2 H. H means height of the cylinder is 2.1 and L is 2.8. Okay. So this is centimeter meter square. Okay. Unit is meter square. After that, given the cost, therefore cost is equal to rupees 500 into area of tent. Okay. And after finding the area of tent, you multiply to 500, then you get the total cost and total cost of the canvas use of the tent. Okay, understood? Okay, now I move to next question. Now, form a solid cylinder whose height is 2.4 and diameter 1.4. Solid cylinder, not open. That means both the end are closed. Solid cylinder means both the end are closed. Both the end are closed. So height 2.4 and diameter 1.4. That means radius 0.7 centimeter divided by 2. Conical cavity of the same height and same diameter hollowed out. So that means same height and same conical cavity hollowed out. Conical cavity. So that means this hollowed out means this portion of material, solid material, removed. Only for this portion is empty. So you saw the figure, only this is empty and this is the CSA of cone and this CSA of cylinder, and this portion is closed because these are solid. Solid means both sides closed, but after drilling and cutting, you make a cone. So find the area. So that means CSA of cone plus area of base of the cylinder plus area of CSA of cylinder. That is the area. Okay, find the total surface area. Therefore, CSA of cone CSA of cylinder, area of base of cylinder. Okay, because this base is up close till now, that is pi RL plus 2 pi RH pi R square. Pi R common, L plus 2H plus R. But L is not given, you find the L. Now height is equal to 2.4, 24 by 10. Radius is equal to 7 by 10. Okay. Now apply the identities. L square is equal to R square plus H square. So R is 7 by 10 whole square. H is 24 by 10 whole square, right? So 49 by 100 and 576 by 100. That is 625 by 100. The L is equal to 25 by 10. That is 2.5 meter. Okay. Length. After that, put the value 1 by 1 length, length, H and R. Okay. This is the final answer. Now I move to next question. You pause the video and after that you note down. Now question number 9. A wooden article was made by scooping out a hemisphere from each end of the solid cylinder. So this is the solid cylinder. And this portion hemisphere is scooping out. Okay. So find the total surface area, and this here given height of the cylinder 10 centimeter and base radius 3.5, and find the area. Okay, find the total surface area. Total surface area means CS of cylinder plus CS of hemisphere, CS of hemisphere, because these two sides are closed, not closed, open. So TSA, CS of cylinder 2 times CS of hemisphere 2 pi RH 2 into 2 pi R square, 2 pi R common, H plus 12. Now put the value. Okay. It's very simple. Now I move to next question, next exercise. Okay, understood? Next. Exercise 13.2 from your textbook, NCERT textbook, question number 1. A solid is in the shape of a cone standing on a hemisphere. A solid in the shape of a cone standing on a hemisphere, that is means this is the hemisphere and cone standing on it, and radii, both their radii equal to 1 centimeter, so radius is equal to 1 centimeter, and height of the cone equal to radius, so height of the cone is also 1 centimeter. Find the volume of the solid in terms of pi. The volume of solid, you know, volume of solid, the volume of hemisphere plus volume of cone. Hemisphere 2 by 3 pi r cube and cone 1 by 3 pi r square. 1 by 3 pi r square common, 2r plus 1. Now put the value of r. Okay. 1 by 3 pi r square is. Okay. sorry, 1 by 3 pi r square h and 2 by 3 pi r cube. You take 1 by 3 pi r square r plus. Now put the value of r and you get the answer in terms of pi. I move to next question. Again, exercise 13.2, question number 2. Russell engineering student was asked to make a model shape like a cylinder with two cones attached to the two ends of the using thin aluminum sheet. Okay, so here a cylinder, make a model, and both sides, this is in the shape of cone. This model, okay, this is in the shape of cone, and diameter of the model is 3 centimeter, that is radius 1.5, and length is 12. Length is 12 means total length of the, and each cone of height 2 centimeter, cone height 2 centimeter, cone height, and volume of the air contained in the model in the Russell, that is height of the cylinder is total length 12, 2 and 2 minus to minus 4, that is 8 centimeter, right? And volume of model, volume of cylinder, volume of two cone, volume of cylinder plus volume of two cone. Volume of cylinder is pi r square h and volume of two cone is 1 by 3 times 1 by 3 pi r square h. But here h1 or h2 I take. This is h2, h1. Because both height are different. Cone height I mention the h1, a cylinder height mention h2. Now pi r square common, h2 plus 2 by 3 h1. Now put the value 22 by 7. R is 1.5 square and h2 is 8 and 2 by third of h1. H1 is 2. Okay, now do the calculate. Now I move to next question. Gulab jamun contains sugar syrup up to about 30% of its volume, and approximately how much syrup would be found in 45 gulab jamun is shaped like a cylinder with two hemispherical end, cylinder hemispherical end with length 5 centimeter, diameter this. So that means this is the gulab jamun. And both ends are hemispherical. Hemispherical. Okay. And radius is given 2.8 diameter to 1.4. This is also 1.4 and total length 5 centimeter. So height of the cylinder is 5 minus 2.8 because this is 1.4, 1.4, 2.8. So 2.2 centimeter. Okay, that is 2.2 centimeter. Now, volume of, find the volume of gulab jamun because one gulab jamun volume of each gulab jamun is equal to volume of two hemisphere, volume of cylinder. So 2 times of 2 by 3 pi r cube volume of cylinder pi r square h. Now you to take common pi r square. 4 by 3 r plus h. Now put the value. This is not given. Pi. Okay. Pi is not given. Okay. So 22 by 7 into r. R is 1.4 into 1.4. 4 by 3 into 1.4. Height is 2.2. Now cut 22 into 0.2 into 1.4. 5.6. 6.6 by 3. 4.4 into 1.4 into 12.2 divided by 3. Don't need the multiply because this is centimeter cube. Now volume of 45 gulab jamun 4.4 into 1.4 12.2 by 3 into 45 15. Okay. Now you do calculate 4.4 1.4 12.2 into 15. This is 11 to 7.28 centimeter. Now volume of sugar syrup volume of sugar syrup 20%. 20 by 30%, not 20%, 30%. After that, you multiply by 30 and divided by 100. That is 338.18 centimeter cube. Okay. So this question is very important because maximum student miss the calculation because different student got the answer different. So carefully multiply each and every part. So it is very important questions. Okay. Now I move to next question. Question number 4. A pen stand made of a wood in the shape of a cuboid. Shape of a cuboid. Here. Cuboid, shape of a cuboid. Okay. Here 1, 2, 3, 4 hole. And this hole is inverted. This is cuboid. This hole is inverted form and it is the form of a cone. So, and find the radius of each depression. No, the radius of each depression 0.5 centimeter and depth 1.4. Find the volume of wood enter stand. So that means this is the cuboid and 4 holes are here and this is a pen stand and this each hole it is in the form of a cone. So that means find the entire volume, total volume of cuboid minus volume of cone. Okay. Now cuboid dimension, length 15 centimeter, breadth 10 centimeter, height 3.5 centimeter, volume of cuboid, length into breadth into height. Now cone radius is equal to 0.5 centimeter, height is equal to 1.4 centimeter. So volume is equal to 1 by 3 pi r square h. 1 by 3, 22 by 7 R is 0.5 into 0.5, this is 1. Cancel 0.2, and after that you calculate. So you do, after calculation you find the volume of entire solid, food, volume of cuboid minus volume of, this is the volume of each cone, and volume of 4 cone multiply by 4, 1 by 3, 22 into 0.5 into 0.2. Okay, volume of 4 cone. That is the volume of entire food. Okay, understood? It's very simple, but concept is very one concept is wants to strong, because without concept can't do anything, because it's a math, because you remember the identities, but your concept is not clear, so you can't apply the identities where it is used. So it is very, very important. Okay, now I move to next question. Question number 6. Question number 6, not 5. A vessel in the form of an inverted cone, and its height is 8 centimeter, and the radius of its top. Vessel in the form of inverted cone, and height, radius given, and filled with water. That means this is the cone, open, and radius 5 centimeter, and height is 8 centimeter. Okay, 8 centimeter. When the lead shot each of sphere radius is 0.5 centimeter, drop into the vessels. So 1/4 of the water flows out. Okay, 1/4 water flows out. 1/4 water flows out. That means number of sphere. Find the number of sphere. You find volume of cone. After that, volume of 1/4 of cone, because from Archimedes principle, displaced water is equal to volume of substance, volume of the substance. So displaced water is equal to volume of the substance. So that means 1/4 of volume of water divided by each sphere volume. That is the number of sphere. Okay. So you find volume of cone 1/3 pi r square is 1/3 22/7, r is 5 square 25, height is 8. Okay. Volume of 1/4 of cone, 1/4 into 1/3 22/7 into 25 into 8. Okay. Now you simplify 4 to the 8. Now, okay. Now 4 to the 8. So that is mean 1/3 into 22/7 into 25 into, after that, that is the volume of 1/4 of water flows out from the cone when you keep the sphere inside the cone. Okay, because water is full in the cone, and when you put a sphere, some water is overflow. So 1/4 of water of overflow. So how many sphere is put in the cone? So volume of each sphere is equal to 4 by 3 pi r cube. 22 by 7, r is 0.5 cube. This means 0.125. So therefore, number of sphere is equal to 1 by 3, 22 by 7, 25 into 2, divided by this, divided 4 by 3, 22 by 7, 0.125. Okay, 22 by 7 cancel, 3 cancel. Now 25 into 2 by 4 into 0.125 to 125 by into multiply 1000. Okay, so that means 25, 5, 2, 2, and 5 to 10. That is 100 sphere. Okay. Now I move to next question. You pause the video and note down the answer. Now I move to question number 6. A solid iron core consists of the cylinder of height 220 and diameter 24, surmounted by another cylinder 60 centimeter and radius 8 centimeter. So I draw both cylinder have different height, and another cylinder is surmounted by this. So this is 220 centimeter height and radius 12 centimeter, and surmounted cylinder height I take this is H1 and this is R1 and this is R2 and this is H2. Surmounted cylinder height 60, radius is 8 centimeter. Find the mass of the cone. 1 centimeter cube iron has approximately 8 gram mass. So this is very simple. Volume of solid, volume of bigger cylinder, volume of smaller cylinder. Formula remains same, pi R1 square H1 pi R2 square H2. 22 by 7 common, R1 square 12 square, R height 220 centimeter, R2 square 8 square, height 6. After calculation, find the mass. Mass given 1 centimeter cube mass 8 gram. So this is centimeter cube, you multiply the 8. This will be get gram. After that divided by 1000 kg, converted in kg. Okay. So after getting the answer, you multiply by 8. That is mean mass is in gram. After that, you divide it by 1000, you get the answer by kg. 7. A solid consists of a right circular cone of height 120 centimeter and radius 60 centimeter. Solid consisting of a right circular cone of height 120 centimeter, radius is standing on a hemisphere. Cone of height and radius 60 centimeter and hemisphere also radius. Find the volume of water left. Okay. And place upright and right circular cylinder full of water such that touches its bottom. Okay. And this main cylinder height is also given 180 centimeter. Volume of water left. So total volume of cylinder minus volume of cone minus volume of hemisphere. Okay. So this is H1 and this side is H2. Volume of water left. Volume of cylinder minus volume of cone, volume of hemisphere, volume of cylinder pi r square H1 minus 1 by 3 pi r square H2 minus 2 by 3 pi r cube. So pi r square common, H1 minus 1 by 3 H2 minus 2 by 3 r. Okay, pi 22 by 7 into r is also here 60 and H1 is 180 minus 1 by 3 of H2 is 120 minus 2 by 3 of r is 60. Then after calculation, this is the this is the after that this is the answer. This will be the answer, and this is answer is get centimeter cube. If you want to given meter cube, then divided by 3 times of 100. That means 100, 100, 100 because cube. A spherical glass vessel has a cylindrical neck 8 centimeter long, 2 centimeter diameter. The diameter of the spherical part 8.5. So this is the height of the cylinder neck 8 centimeter, radius 2 centimeter, and this spherical radius is 8.5. The diameter 8.5. The radius divided by 2 centimeter to 85 by 20, 17 by 4 centimeter. Okay. Now given is volume is A345, but it will correct not ask you. So you find volume of cylinder plus volume of hemisphere. Volume of cylinder plus volume of sphere, not hemisphere, sphere. So that means pi into r square 4 height 8 and 4 by 3 pi r cube 17 by 4 cube. Now after that you calculate, and if the result exactly 345, then it will okay, otherwise not correct. Okay. Now I move to next exercise. (13.3). A metallic sphere of radius 4.5 centimeter melted and decast into a shape of cylinder of radius 6 centimeter. Find the height of the cylinder. That means sphere and cylinder. Melt of the radius of the sphere 4.2 and melt of the cylinder is radius is 6 centimeter. Okay, find the height of the cylinder. So that means sphere melt. After melting the sphere, he made a cylinder. So volume of both of them are equal. The volume of sphere volume of cylinder. So 4 by 3 pi into 4.2 cube. So that is pi into 6 square into 8. Pi cancel. Now after that you calculate the result. Okay. 4.2, 4.2, 4.2 and divided by 6 into 6. Now do calculate easily. Okay. Now move to next question. Question 2, exercise 13.3. Okay. Now metallic sphere of radius 6, 8 and 10 centimeter are melted to form a single core solid sphere in the radius of the resulting sphere. So that means volume of 3 sphere, volume of 3 sphere is equal to volume of the resulting sphere. So volume of sphere 4 by 3 pi r cube. I take common 4 by 3 pi, radius 6 cube, 8 cube plus 10 cube. Volume of 3 sphere. And 4 by 3 pi r cube, 4 by 3 pi cancel. After that calculate and cube root of I find. Okay. And 6 cube, 8 cube and 10 cube put here. And after that you make a prime factor. Okay. And cube root of r, so you will find. Now next question 3. A 20-meter deep well with diameter 7 meter is dug and each from digging is evenly spread out to form of a platform 22 meter and 14 meter. Find the height of the platform. This is the well. Well, and here made a platform. Okay, so that means volume of earth, that is mean volume of cylinder. Volume of earth mean pi r square h 22 by 7, radius is 7 by 2 into 7 by 2. Okay, and height is 20. $770 centimeter cube. Now platform length is given, and these are spread over this. These are spread out to form a platform. It will form cuboid. So length and breadth given. So volume is equal to length, breadth into height. So volume of platform, length, breadth into height. Length 22 and breadth 14, height not given. So according to question, this volume H is equal to volume of R. Now you calculate H is equal to 770. 770 divided by 22 into 14. Okay. Now question number 4. Same way, and it is also a well, and you make a embankment. Embankment, it is circular shape. Well, volume of earth, same way, you read the question first, then you do the solve. Radius 3.1.5 and that length 14. Okay, Now after that you calculate the result. Now you observe here, this is circular shape and you are spread eventually this portion. So you need the area of this. This is the inner radius 1.5 and thickness is I think 4 meter. 1.5 meter, thickness is 4, so that is the radius of this from center 4 plus 1.5, 5.5. At first find area of embankment. Pi R2 square minus pi R1 square. R2 means I take outer radius, inner radius R1. So you outer circle minus inner circle, that is mean this area. 22/7 R2 mean 5.5. This is 1.5. Don't split the square. You apply the identities a square minus b square. So 22/7, 7 and 4, cancel 88 centimeter square. Now after that, volume of embankment, area into height. According to question, area into height is equal to this. Now you find the height. Okay, understood? Both question 3 and 4 are important. Now I move to question number 5. A container shaped like a right circular cylinder having diameter 12 centimeter, height 15, full of ice cream. And radius is 6 centimeter and height is 15 centimeter, full of ice cream. You find volume of cylindrical cylinder, that is find the volume of ice cream. Pi r square h, pi into r means 6 square, height means 15 centimeter. So pi into 36 into 15 centimeter cube. After that, the ice cream is filled with a cone of height 12 centimeter and diameter 6 centimeter having hemispherical shape on the top. So that means this is the cone shape and hemispherical top. So volume of each ice cream, and here length and height given. Height of the ice cream is 12 centimeter and radius 6 centimeter. Radius 3 centimeter. So volume of each ice cream volume of cone, volume of hemisphere 1/3 pi r square each, 2/3 pi r cube. 1/3 pi r square common, h plus 2/3. Okay. So after calculation, but don't put the value of pi, because after calculation you divide this by this. Volume of cylinder, volume of each ice cream, that is total number of ice cream. Okay. You do, right? It is easy. You don't calculate this. You put the value of this here. After that, 1/3 pi, r is 3, 9, h is given 12, and 2/3 into radius 3, that is 3 cancel, 12 plus 2, 20, 14. 1/3 pi 9 into 14. After that, number of ice cream divided by 1 by 3 into 5, 9 into 14. Okay, you get the answer. Now next question I move. How many silver coin 1.75 centimeter diameter of thickness 2 millimeter? Silver coin is also a cylinder and diameter radius is 1.75 by 2, 175 by 200. And okay, now radius and radius height. Okay. How many silver coin? And thickness mean height 2 millimeter and convert to centimeter 0.2 centimeter. Volume of silver coin pi r square h. H is 0.2. Okay. Now this is silver coin volume. Calculate this result and cuboid volume is equal to length into breadth into height centimeter. So number of silver coin, volume of cuboid divided by volume of silver coin, because you make the silver coin from cuboid. So number of silver coin, volume of cuboid by volume of silver coin, each silver coin. Okay, you can do this. I move to next question. 7. Cylindrical bucket 32 centimeter height and radius of the base 18 centimeter is filled with a sand. Cylinder height, radius, find volume pi r square h. R is and this sand this bucket is emptied on the ground, and make a conical shape. Find the height of the radius. Find the radius. So height given, cone. Height is also given 24 centimeter. And volume 1 by 3 pi r square h. 1 by 3 22 by 7 r square into h. H is 24. Now according to question, this volume both are same. 22 by 7 r square into 8 is equal to 22 by 7, 18 multiply 18 multiply 30. Now you calculate the result of r square. Now this cancel. R square is equal to 18 into 32. 32 divided by 2429. 22 and 9 to 16. So 16 square root 9 and 16 square root 4, 36. After that, apply L square is equal to R square plus H square. You will do find the length. Okay, slant height. Length not slant height. Now we move to question number 8. You pause the video and do the answer. Write the answer. Okay, now move to next question. 8. Water is a canal 6 meter wide, 1.5 meter deep and flowing at the speed of 10 km per hour. Canal 10 kilometer per hour, that is length, 10,000 meter, okay, per hour, 1 hour flowing, and breadth is equal to 6 meter and depth is equal to 1.5 meter. Now volume of water flowing in 1 hour is equal to length into breadth into height. Okay, so this is the put here 1 10,000, 6 into 1.5, 90, 90 to 9, 1, 2, 3, 4, 1, 2, 3, 4. This is meter cube. The volume of water flowing in 30 minutes. 1 hour given here, 30 minutes divided by 2. 45,000 meter cube water flowing. And if 8 centimeter standing water is needed, so that means this water fall on the ground, and this ground has length and breadth, that is area into height, that is volume. So according to question, area into height is equal to volume of flowing water, that is 4500. Now area is equal to 45,000 and 8 centimeter. This is meter. Okay, this is meter 0.08. Convert in centimeter. Okay, so now area will get a meter square. If the value will much more, then you will divide it. You will convert in centimeter. Okay, so that's no problem. And now I move to next question. Question number 9. A farmer connect a pipe internal diameter 20 centimeter. Pipe radius is 10 centimeter into a cylindrical tank and 10 meter diameter to radius 5 meter and depth 2 meter, and water flowing at the pipe 3 kilometer per hour, that is height is equal to 3000 meter. 3000 meter per hour, and this is 10 centimeter to 0.1 meter. Okay, now how much time will it fall? So volume of water in 1 hour, that is pi r square is 22 by 7. R is also 0.01 and 3000 22 by 7, 30 meter cube. And volume of cylinder pi r square is 22 by 7, r is 5 to 25. So time needed, because this is the total volume of the cylinder, because this water is filled that cylinder. So volume of cylinder divided by this volume of water per 1 hour, you get the time. So therefore time 22 by 7 into 25 into 4 volume of cylinder divided by volume of water flowing in 1 hour. 22 by 7 into 30, this is cancel. 30, 5, 6 ja, 5, 5 ja, 2, 2 ja, 3 ja. Mhm. This is 2, this is 2, this is 2, this is 2. Okay. So 5, that is 130. 30. 5 5 ja 5 6. 2 3 ja. Okay. So 5 by 3 hours multiply by 60. 100 minutes. Okay. 100 minutes. Now you pause the video and note down the answers. And if you have a problem and you ask me again, then I will explain. So okay, bye. Take care.